Hello students, welcome to my YouTube channel. In this video lecture, I am going to answer all the questions from sample paper number 1, RTR BALI navigation book. So let's start. And attention, this book is the 4th revised edition book. If you tend to have any other edition book like the 5th one, the 6th one, the 7th one, no problem. The questions are still the same in all these sample papers of all these new edition books. So let's answer question number 1. Question 1. Gyro rigidity increases with what? Now your gyroscope instruments have two main properties, the rigidity and the second one is precession. Now rigidity is that property the which will increase with increasing RPM and concentrating mass at the periphery. So option B is the correct answer. Gyro rigidity increases with increasing revolutions per minute and concentrating mass, that is availability of presence of mass at the periphery means boundary. Okay, boundary. Next, question 2. At what approximate date is the earth closest to the sun? That means perihelion. So remember, I have said this many times. You can also watch my other lectures on time chapter, in which I have solved all questions related to time from RK Bali, Oxford key periods. I have explained this concept many times there. Now, the Earth revolves around the Sun in an elliptical orbit. So, this is the elliptical orbit of the Earth around the Sun. Okay, let's say here is the Sun situated at one of the foci. So, this focus, here is the Earth. Okay, now you can see here at this position, the Earth is the closest to the Sun. At this position, when this Earth will revolve around the Sun following this orbit, it will at some point of time, it will end up being here. This position will be called aphelion. It will be called aphelion position. Okay. So this is perihelion. This is aphelion. That means here the earth is closest to the sun and here it is far away from the sun. Now perihelion happens in the beginning of Jan, that is 4 Jan. Aphelion happens in the beginning of July, that is 4th of July. Okay. So at what approximate date? So it is beginning of January, 4th Jan, 3rd Jan, whatever. So option C. Question 3. Convergence. The definition of convergence or convergency. It is the angle between two meridians, longitudes like this. Okay, or it is the angle or the difference between two great circle tracks. So there are two definitions. It is the angle of inclination of meridians towards each other, angle at which a meridian cuts the equator, the angle of inclination of one latitude with another. So the correct answer is option A. Now, parallels of latitude. All latitudes are parallel to one another. So let's say this is your Earth. Okay. So this will be the equator. Right? This will be the equator 0 degree north-south latitude. So other latitudes in the northern hemisphere will be like this 10 degree, 20 degree, 30 degree, 40 degrees, so on and so forth. Similarly, you will have many other latitudes in the southern hemisphere like this. Correct? So all these latitudes are parallel to one another. They do not intersect across each other. So option Charlie can be eliminated. Angle of inclination of one latitude with another is wrong. Next, question number 4. The initial great circle track from A to B is what? Now A is at 27 degrees south, 30 minutes east. Bravo is also at the same latitude. That means both locations are at same latitude. One is in the eastern hemisphere, 17 degree 45 minutes. Another is also in the eastern hemisphere, 29 degree 15 minutes. So let's draw this. So let's say this is the representation of the Earth. This is the longitude 0 degree meridian. So there is one latitude 17 degree 45 minutes east. Another longitude 29 degree 15 minutes east. Correct? And both are in the southern hemisphere. So let's say this is your equator 0 degree. Now both are in the southern hemisphere 27 degree 30 minutes south. Since it is in the southern hemisphere, the great circle track will pass through the nearest south pole. So this will be your great circle track. This will be your line track. Okay. So I will draw another diagram here. Right. So your point A is here. Point B is here. Now we have to find great circle track from A to B. We know that line track from A to B is 0, 9 or 0 because B is to the east of A. B is to the east of A. Let's say this is your northern hemisphere, then B is to the east of A, and line track B to A will be 270 of westerly direction. So line at A 0, 9 or 0, line at B 270. Now we have to find great circle track A to B. That will be equal to line track A to B plus convergency angle. We know that a great circle A to B is this big angle. It is made up of two parts, the line part and this extra small part which is your convergency angle. Now what is convergency angle? Convergency angle is nothing but the angle between your line track and great circle track. So to find convergency angle, we will find convergency, which is d long in degrees into sine of latitude. What is difference in longitude between between them? 29 degree 15 minutes minus 17 degree 45 minutes, which is 11 degree 30 minutes. Sine of latitude. What is latitude? 27 degree 30 minutes. So sine of 27 degree 30 minutes is 0.46 multiplied by 11 degree 30 minutes is 5 degree 18 minutes. So approximately 5 degree. So convergency angle will be half of that, that is 2.5 degrees. So substitute that values here. Great circle at A is line at A 0, 9 or 0 plus convergency angle 2.5. So 0, 9 or 2.5 degrees is your great circle track at A. So correct answer is option alpha 0, 9 or 2.65. Question number 5. What are the consider the following statements on sunrise and sunset. In May, sunrise occurs later at 45 degree north than at 45 degrees south. That means the meaning of this statement is that in the southern hemisphere, we will have sunrise happening much earlier. Let's say 5 in the morning, and sunrise will happen later than that in the northern hemisphere. Let's say 7 in the morning, so 2 hours later. That is the meaning of this statement. We will check that. In November, sunset occurs earlier at 45 degrees south than at 45 degree north. Meaning of this statement is sunset will happen much earlier in the southern hemisphere than in the northern hemisphere. For example, if sunset happens at 6 o'clock in the southern hemisphere, the sunset will happen at much later time, let's say 8 o'clock in the evening in the northern hemisphere. At equator, sunrise and sunset occur at quite regular times throughout the year. That is the meaning of this statement. At equator, sunrise and sunset occur at quite regular times. So option number A, in May sunrise occurs later at 45° north than at 45° south. Now let's say this is the representation of your earth. This is your equator here. This is Tropic of Cancer. This is Tropic of Capricorn. Now, in the month of May, what happens in the month of May? Where is the location of the sun in the month of May? Now, in December, the sun is over Tropic of Capricorn. In March, the sun is over the equator when we have spring equinox. After March, that is April, May, June. Okay, in June, the sun will be at Tropic of Cancer in the northern hemisphere. But the month given to us is May. It is not June, it is May. So that means in the month of May, the sun won't be correctly or accurately at 23.5° north. It will be at some latitude below that. Let's say somewhere here. Okay, it will still be in the northern hemisphere, but at a lower latitude, a latitude lower than 23.5° north. That is where the sun will be. Correct. So that means if sun is in the northern hemisphere, you will have summers in the northern hemisphere, and at the same time you will have winters in the southern hemisphere. When you have summers, you have longer days. When you have winters, you have long nights. Long days means sunrise will happen much earlier. Okay, so let's say sunrise happens early, very early, depending on your latitude. Winters means long nights, means sunset will happen early. Sunset will happen early. So here it says May sunrise occurs later at northern hemisphere. That is wrong. In November, in the month of November, sunset occurs earlier at 45 south. Now in the month of November, now in the month of June, we have the sun on Tropic of Cancer. Then we have September. In the month of September, the sun will start its downward trajectory. In the month of September, it will be again situated over the equator. We will have autumn equinox. After September, the sun will move down further and it will go to Tropic of Capricorn. Okay, there in the month of December. So in the month of December, now I'm going to erase this. Okay, in the month of December, we have the sun situated on Tropic of Capricorn. That means this means that you will have summers in the in the southern hemisphere. You will have summers in the southern hemisphere in the month of December, and you will have at the same time you will have winters December, Jan, Feb in the hemisphere in the north hemisphere in the month of December. Now winters means long nights. That means sunset will happen much earlier. Summers means long days. That means sunrise will happen much earlier. Okay. So in this statement, it says that in November, sunset happens earlier at southern hemisphere. Is that correct? No. In the month of November, that is November, December, Jan, you have summers in the south hemisphere. Summers means long daytime, short night time. So sunset will be delayed. Whereas in the northern hemisphere, you have winters, the season of winter. In the season of winter, you will have long nights, long evenings. That means sunset will happen much earlier, 5 in the evening, 4 in the evening, depending on your latitude, right? So statement 2, statement Bravo is also wrong. So we are left with option Charlie. At equator, which is midway between the two hemispheres, sunset, sunrise timings are more or less uniform throughout the range of the seasons. So option C is the correct answer. Question 6. When approaching the international date line from the east, what will happen? So very important. When you're considering time numericals, time concepts, it's very important that you draw the surface of the earth with respect to the north pole. So this is how you draw this diagram. And now all easterly directions are anti-clockwise when you view it from the north pole. Okay. Now in this question, you are flying a direction of east. You are flying a direction of east. Okay. So when you cross this international date line, that is anti 180 degree east-west anti-meridian, what happens? So when you travel easterly direction, you leave eastern hemisphere and enter western hemisphere. So what will happen? When you fly from east hemisphere to west hemisphere, the result or the consequences are your date decreases. Date decreases. That means, let's say you left. It's 2nd April in the eastern hemisphere. It's 2nd April in the eastern hemisphere. When you cross this anti-meridian and enter western hemisphere, it will be 1st April. Okay, so you have lost a date. There has been a decrease in value. 2nd April has become 1st April, and day is gained. So it was 2nd April in the eastern hemisphere. When you enter the western hemisphere, the date is 1st April. So now you have gone back in time. That means you have gained an extra day to live. Okay, so again you will live the whole day of 1st April. Then again next day you will be living the 2nd of April. So you have gotten an extra day to live. So that is the advantage when you fly from east to west. Date decreases, day increases. Okay, or you gain a day. But when you fly from west to east, what will happen? West to east means clockwise direction. West to east means clockwise direction. So when that happens, the date west to east means a date increases. It is 1st April in the western hemisphere. When you cross the anti-meridian and enter eastern hemisphere, the date becomes 2nd April. Because all eastern longitudes run ahead in time compared to their western longitudes. So therefore, eastern hemisphere will be much ahead in time compared to the western hemisphere. So date increase and day is lost. So 1st April has become 2nd April. Okay, so you have lost a day. Day is lost. So when approaching international date line from the east, you should increase your date. Increase your date by an extra date at the first midnight you experience. Should be prepared to decrease your date by 1. Should be prepared to increase your date by 1. So should be prepared to decrease your date by 1. Option Bravo is the correct option. Next. Question number 7. When magnetic direction is 270 degree, true direction is 265 degree, what is variation? Now there are two direction and magnetic direction. Correct? Variation is the link between true direction and magnetic direction. Now true direction is 270 degree, magnetic direction is 265 degree. So variation will be 270 minus 265, 5 degree. Now whether this variation will be west or east. Now if true is more than magnetic, that means magnetic is less than true. So variation is east. Remember the mantra that we always use, variation east, magnetic is least. Means magnetic direction is less than the true direction. And when magnetic is more than true, we say variation is west. That means variation west, magnetic is west. Magnetic direction will be more than the true direction. So when magnetic direction is 270 degree, True direction is 265 degree. Variation is east, that is 5 degree east. Okay. Question number 8. Zero variation occurs only at equator, 5 degree west in northern hemisphere, could occur anywhere. So zero variation occurs anywhere. Okay, zero variation is 0 degree value. So that can happen anywhere on the earth, not necessarily the equator or the poles or in the western hemisphere, nothing like that. It can happen anywhere. Aircraft radio equipment which emits on a frequency of 4400 megahertz is what? 4400 megahertz is 4.4 gigahertz. The only equipment that operates on this frequency is radio altimeter. Weather radar operates on the frequency of 9.675 gigahertz. Primary radar operates in the frequency band of ultra high frequency. So we are left with option Charlie, radio altimeter, which is a super high frequency band. Question 10. Drumline distance between A and B is what? A is given 60 knot 2 degree 30 minutes east. B is again 60 knot 7 degree west. So one is in the eastern hemisphere, another is in the western hemisphere. Both are at same latitude. Okay. So if I have to represent this, I will do it something like this. There is a prime meridian in the center. 7 degree 30 minutes west and 2 degree 30 minutes east. Correct? Both are at same latitude, that is 60 degree 60 degree north. So the Ramline distance between these 2 points will be how much? Ramline distance equals to d long in minutes into cos of latitude. So d long 7 degree 30 minutes plus 2 degree 30 minutes is equal to 10 degree multiplied by 60 into cos of latitude cos of 60. So 600 into cos 60 is half. So that is 300 nautical mile. So correct answer is option Charlie. Simple. So this concludes our lecture. I hope you have understood all these 10 simple questions, how to solve them, the concept behind each solution, behind every solution, and how to do these sums. I wish you all the best. Share this channel with your friends, this video lecture with your friends who are also preparing for this exam. Subscribe if you haven't yet, and hit the like button if you have liked this video lecture. Thank you for your time.